It's new. It's shiny. It's IPv6 configuration. And it's fantastic. I was just going through it before I started this recording. I was like, I better brush up a little bit and do run through some of the commands I'm doing. And as I'm doing, I'm like, I should try. Ooh, this would be cool. Ooh, let's add this. So this is gonna be fun. We're going to look at the IPv6 configuration. First off, assigning the addresses to your router. Just kind of the base. How do you get started with IPv6 on your router? We'll look at routing IPv6, both static routing, and I want to roll out full IP or OSPF version 3. And then we'll look at, finally, how do we cut over from IPv4 to IPv6? To illustrate IPv6, I decided to go with a simple topology. When you see how this is configured, you're going to immediately be like, hey, I can see how this goes to any size organization. So I've got a couple routers, nothing on them at all except a host name. So let's get started. I'm going to bring up the GNS3 console. Let's bring up the console for router 1. And while we're here, might as well grab router 2. Now, just to get oriented, I'm going to do on each one of these, I just have literally a base config that has a host name. No IP addresses, everything's shut down. These things are out of the box. Or out of the emulator, however you want to say it. So there's nothing happening here. First thing I want to do is start assigning the addresses. How do I do that? Well, unlike IPv4, IPv6 routing is turned off by default. You may have seen, I don't know if you've seen this at any point in your Cisco journey, but if I go to the global config mode and type in IP routing, and hit enter, that turns on routing functions. Essentially, your router is not a router until you type that command in. Now, since the early days, Cisco has been shipping routers with that command in the running config by default, so you don't have to do that. However, they do not enable IPv6 by default. So first off, I will say you need to make sure that your iOS version supports IPv6, and you'll find out real quick if it doesn't, because you'll go to type this command. It's IPv6 unicast-routing. Hit the enter key. That command turns on the IPv6 features. Essentially, it's not an IPv6 router until you type that command in, and now it is, and that command is not in there by default. So now let's go in and assign some addresses. I'm going to look back at my topology here. Router 1, you can see my main networks. Now, before I just type those in, let me talk about them. Notice that we have one network here, 2001:55::1. What does that mean? Well, you remember from the concepts nugget that this represents a whole bunch of zeros, 0:0:0:0, and you'll see that commonly. Now, remember, each one of these represents 16 bits of information. I'm going to change to purple. Just writes better. So each one of these represents 16 bits of information. And then, so you see right here, there's up to 32 bits. Now, the subnet mask is 64 bits. So immediately I'm going, okay, well, I know in every single IP address, whether it's IPv4 or 6, there's always two portions. There's the network and there's the host. So when I'm trying to identify the network for this, I'll go, okay, well, I've got 32 bits and then a whole bunch of zeros that are kind of vanished behind those double colons. So my network must be, if I were to write it, without any shortcuts, it would look like this. 2001:00:00:00:00. That would be my networks. Now, of course, with our shortcuts, we've got 2001:55:00, right? That's a shorter way of writing the network statement because I can drop the leading zeros out of there. And that represents the first 64 bits. Now, the last 64 bits, notice I do :::1. So if I were to say, well, what is the host? The host, and I'll just write the short version, is 0:0:0:1. So, you know how if we're used to IPv4, we have like 192.168.0.1 that's going to go to the gateway or something like that. Well, it's the same thing here, except we've got a really big network, 2001::55:00, all of that. That identifies the network, and a really big host, but it all boils down to the same concept. This is a shorthand of writing, I have the first IP address in that network. Okay. So down here, router 2, just to describe this, we've got the same thing. 2001:56::1. So same concept. We've got 4 octets, since it's a /64, represent the network. 2001:56:0:0. That represents the network. And then 0001, 0:0:0:0:1 1 represents the host. Got that? Now, looking at this, we were a little more descriptive. We said, okay, the serial link is going to have a network of 2001 colon 210 colon 10 colon 1. Now, again, 4 octets, right there, that's 64 bits of love. So that is our network. Now, the host is still the colon colon 1, so our host is 0 colon 0 colon 0. You getting used to it? You see, it's going to be long. It's bigger addressing if we write it all out that way. But using these shortcuts, you see how these shortcuts are so handy because there's typically going to be a number of zeros in the IP address, at least for your router, and that's the one that we care about. So you can see that this is on the same network as this. One of them is the first address, and one of them is the second address. Is that all making sense? Good. Okay, so let's come down here to router 1. And I'm going to go into fast Ethernet 0/0. So router 1's got FA00 on the left there and serial 00 on the right. So let's power that guy up. I'll do a no shutdown, get him going because I know he's administratively down. And we'll do now IP instead of IP address, right? We're now going to do IPv6 address. And you'll see this so often. Cisco did such a great job just saying, you know what? Concepts, for the most part, are the same in IPv6. We still have, show IP routes. It's just now it's going to be show IPv6 routes. So it's not like you have to relearn all the commands that you know. We're still assigning address, but instead of IP address, it's IPv6 address. Pretty nice. Let me hit the question mark. Check this out. Couple things that you could do is a link local address. Come on. I know it's rusty already. Think back to the concepts. Link local is you can actually pick what address it uses to communicate on its local subnet. Remember that was the FE80 address that it's going to generate by itself. Now, that being said, I'm saying it because it's going to generate it by itself. We don't have to type it in. Although, being on a router, you might just say, you know what? I like manually typing it in. So you could do that. Down here, and notice this one doesn't have a subnet mask because it doesn't need one. Link local never talks outside of its own network, its own little FE80 world. Doesn't pass another router, so there really is no network to it. However, this one, that's how you assign a real address. And it says, okay, well, that's what we're going to do. Then underneath we can see auto configuration. This is where it can query another router and say, hey, what network am I on? And it'll kind of fill in its own host ID based on its MAC address. So if you want to do that, you can, but come on. But we don't like auto things. We want to do it ourselves. So I'm going to type in IPv6 address 2001 colon 55 colon 1/64. Totally will take that. Just like that. Look at that. 2001 55 colon. So it's going to do that. Now, I can't go on. I've got to verify it. I must show caps lock, show IPv6 interface brief. Yes, they took my favorite command and moved it over. It looks different though. They knew they couldn't fit these big old addresses on one line. So look at this. We've got fast Ethernet 00. It is up and up. You remember line protocol and line protocol line. Why is my mind? Oh, status and line protocol. Right? Is that right? Show IP. Having one of those moments. Yeah, status and protocol. There we go. So it's the same thing here. Status, first up, protocol, second up. So right there, you see the link local address. Now that's pretty cool because look at this. You can see, okay, we've got some MAC address info, but look, right in the middle, remember that FFFE? It kind of squishes it in there to give it enough octets to be a 64-bit address. So it's right there. We're verifying that. Okay, looks good. And then right here, we've got the address we just assigned. So I'm able to verify that. Good. So let's get back into serial 0/0, no shutdown. And we'll do IPv6 address 2001 colon 210 colon 10 colon 1 colon. I keep hitting the caps lock. Colon 1/64. Come on, we want to verify that. So we can see it's got its own little link local address. Now, check it out. Same link local address as above. You see the FE80 colon and then blah. Is that it? Whoa. Can we do that? Can we do that? Yes, we can do that because that address never leaves its local subnet. So when it's talking on the serial link, it's not like it's going to get confused and say, oh well, which link is this coming in on? You can use the same link local address for all your interfaces if you want to, because it only communicates on that interface. It never goes beyond that world. But right below, we see that's good. So okay, enough descriptions. Let's just blaze through router 2, right? This will be our good review router. See if I can move it up here to see all the addresses. Please find a spot. Let's do this. There we go. So let's go into global config, IPv6 unicast routing. We turn it on. Interface fast Ethernet 00. No shutdown. IPv6 address. Looking over there, 2001 colon 56 colon 1. You follow? Good so far? Exit back out. Interface 0/0. We'll do IPv6 address 2001 colon 210 colon 10 colon 1 colon 2/64. No shut. No shutdown. There we go. So go back and do a show IPv6 interface brief. And so looks good. I'm feeling warm and fuzzy about that. Let's do a show IPv6 interface. Serial 0/0. We can see a little bit more about it. Notice it says, okay, I've got my global unicast address. Remember we talked about the different address types. Global unicast address is the one. It's the global address that it's using. This is like a public address we can use out on the internet. Right above it, you see the link local address. This is the automatically generated address. And it also says I've joined these multicast groups. So multicast groups are kind of like I've tuned in to these radio stations. I'm listening on my local network for these kinds of, think of it as, I'm going to say it broadcast, but they just call them unicast nowadays. So I'm feeling the need for a ping right about now. Yeah? Let's do a ping. Let's do a show CDP neighbor. Sure enough, there it is. Show CDP neighbors detail. Check it out. CDP has been upgraded, my friends, to support the IPv6 addresses. So it says, okay, I've got router1.lab.local, which is its host name. It sees router1 at that address. So how do I do this? I can't type in ping because ping is an IPv4 flavor. I have to type in ping IPv6 followed by the address, and that's I'm on router 2. So I'm going to go to the other side, 2001 colon 210 colon 10 colon 1 colon 1. Awesome. Okay, so working. Yeah? Feel good? Okay, so I know someday I'm going to be typing this. I'm going to be like, these addresses are so long and mistyping. And there's going to be some young kid who comes up and is like, what do you mean? That's just the way the world works. What are you talking, like old IPv4? Are you grab the can? I can totally, somebody's going to mock me someday on how painful these addresses are to type in. But for now, they're painful. I like IPv4, typing those better. So router 1 shows CDP neighbors. He's seeing router 2. Let's just go the other direction to feel good. 2001 colon 210. Whoop. Forgot this. IPv6. 210 colon 10 colon 1 colon 2. So we're doing good. We're getting the end-to-end communication. But wait. Wait, there's more. How do I let's see if I can ping over here this 2001 colon 56 colon 1, right? Up here we've got 2001 55 colon 1. So I'm on router 1. Let's do it. Let's do a ping IPv6 2001 colon 56 colon 1. What do you think? Work? Will it work? Well, no. Nope, it will not. Why? Because it doesn't know how to get there, even though it's like, hey, I've only got one router. The router doesn't think that way. It's looking at its routing table. So let's do that. Let's do a show IPv6 route. And the router's like, hey, I know about this stuff. And it says, okay, I'm connected to this network. As a matter of fact, I've got a local address. It's a little different than the IPv4 routing table, right? I've got a local address of this. See, that's the address. This is the full network I'm connected to. It's my fast Ethernet 0/0. No metric, no administrative distance, because it's right there. I'm plugged into it. So the routing table is not able to see, router 1's not able to, let's squish them up here, not able to see router 2's network over there. I don't see it on the routing table. So let's do a little static routing, you say? I'm going to do a IPv6 route. Instead of an IP route, it's IPv6. Tell me you're not feeling good? If you're feeling good with IPv4 concepts, these should be like, oh, that's cool. So it's just the same command with v6 after it. So IPv6 route. Where do you want to go? I want to reach 2001:56 actually. Colon done. Huh? Can I do that? Yeah, because I want to reach that whole network. Look at me, I'm waving my finger at the screen. I want to reach this full network right here. I don't just want to reach the .1 address, right? And this is the way that we annotate the whole network. We're saying that's the network, and the first 64 bits represents the network. So the router automatically fills in, okay, :0:0 there, got it. Okay, so now tell me, admin, where do I go to get to that network? And I'm going to say, well, actually, you can go, shrink your window a little bit, and you can go right here to router 2. So I'm sitting on router 1. I need to go right here to get right here. That's the next hop address. So let's do that. Now you could put in an interface if you want to. I just don't like it. So we'll do 2001:10:1:2, right? So I'm saying I want to route to this network, and I'm going to use this guy to get me there. Good? Okay, we can also come in here and say, oh, well, here's the different administrative distance. That's actually to create something called a floating static route. You'll learn about that when you get to the CCNP world. You can also say this is just a multicast route or just a unicast route. We're not going to worry about all that. Hit the enter key. So now, show IPv6 route. Let's take a look. Static, it looks good. I'm feeling good about that. So let's do it. I'm going to go on router 1 and ping IPv6 2001:56::1. Yes, I need a clapping sound effect or a Bon Jovi like raw. That's awesome. So we're good. So good. Now okay. Hang on. Where are we on this thing? I've assigned the addresses. I've verified those addresses. I see that they're there. I've configured static routing. Now, let's look at dynamic routing. It's different, but I think you'll like it a lot better than the old IPv4 way. Okay, so I've got this static route on here. So let's get rid of that, right? No, it's gone. So now my pings will fail again to that address because it's saying I don't know how to get there anymore. You've taken my route away. So I'm going to go to router 2. Let's set up OSPF. How do we do it? Okay, go into global config mode, and we're going to use IPv6. Remember, we would type in router and then what routing protocol we want. That's IPv4. Okay, put that in the back of your mind. So how do we do it now? IPv6 router. Woohoo! Go Cisco. Now this version of the iOS only supports RIP v6, and actually most people call it RIP-NG, next generation. Can't believe RIP made the jump. And OSPF, but there are flavors of every protocol for IPv6. There's EIGRP for IPv6. There's BGP, ISIS. I mean, they've all kind of gone through the evolution and become IPv6 compatible. It's just my iOS version doesn't do them. So I'm going to type in IPv6 router OSPF, and just like the IPv4, I have to type in a process ID. Just like remember I said it's like task manager that goes through, and we've got the process, the PID that it's just a number. Just got to remember it. That's all there is to it. So I'm going to type in process ID 1. Now, unlike the IPv4 version of OSPF, there's nothing really that goes under here. That's what's cool. Remember before, this is where we would come in and do network, blah blah blah, wildcard mask 0, 0.0. Obviously, I'm just throwing stuff up there. But check this out. Network ? Huh? I don't know what you're trying to say. The network command is gone. Thank you, Cisco, for getting rid of it, because now they have a better way. The only thing that we see here, I know some of you are like, whoa, what was that? OSPF could not pick a router ID. What's that? Well, in OSPF, as soon as you start the process in IPv4, it will pick what's called a router ID. The router ID is something that looks like this. Well, not exactly that, but it will be an IP address. But if you read the documentation, it'll say, no, it's not an IP address. It's just a number that looks like an IP address that the router uses kind of like as its name when it's talking to OSPF router. So for instance, if router 1 said, I want to have the router ID 192.168.0.1, then it would just introduce itself. It would say, hey, router 2, how's it going, man? I want to trade some routes with you. My name is 192.168.0.1. And router 2 would go, oh, great. Hey, my name is, and whatever you type in. You can type in whatever you want. You could make up, and you could say router 2 has a router ID of 255.255.255.1 if you want to. It doesn't matter, and that's why they say it's not an IP address. It's just an identifier. Now, here's the way it works in the version 4, or I should say v3, the older version of OSPF, is the router looks at all of its interfaces, and it says, okay, which one has the highest IP address? That will become my router ID. It just kind of picks one. That's what it does. But here's the problem. OSPF looked around, and it's like, I can't pick one. Why? Why do you think that is? Because it doesn't have any IPv4 addresses. Even though we're doing all this IPv6 config, I can do a show IP interface brief, and it's still like, I've got nothing. Nothing. Oop. Nothing. 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 Nothing's there. I don't have any IPv4 addresses. So now if you have a truly native router, native, not like Wild Banshee with a spear, like native only IPv6, then it's going to need you to type in what the router ID is. So I'll just say, hey, this is router ID 2.2.2.2. And that's it. That's it. Seriously. Do a show run. I'm going to filter it down. I'm just going to say, show me the section that has router OSPF. Actually, it's, well, I guess I can type this. It'll still find it. Router OSPF. Comes back, it's like, this is all I got. I got router OSPF 1, IPv6, and I've got router ID. So now it's like, well, how does it know which networks to run on? Remember the old network command? We would identify which networks, and then we could send hellos out those interfaces, all that. We don't do that anymore. Now in the IPv6 version of OSPF, I can go in and do interface fast Ethernet 0/0 and put the interface into the OSPF process. I think this is a lot easier. I don't have to explain the wildcard mask and how the network command works. Now all I have to do is go in here and do IPv6 OSPF. And then I say, well, I'm going to associate this with process ID 1. And I'm going to put this in area 0. Now you remember the area was just in this course. We're only going to talk about area 0, but the area can designate where you have summary routes and all that kind of stuff. But that's it. No network command, no wildcard mask and matching, and oh, does this interface get swooped in there? Nothing like that. Now I just go interface by interface and say, okay, interface fast Ethernet 0/0, you're running OSPF. Done. Interface serial 0/0, up here, well, here, I'll type it in. IPv6, OSPF 1, area 0. You're running OSPF. Done. Right? So now it's the same function as the network command, but a lot easier to understand. Now I am sending hello messages. Hello, 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 out this interface. Hello, hello. I'm going out this interface too. And I'm advertising these networks. I'm saying, I'm going to tell people about the 2001-55 network. I'm going to tell people about this network. Now this guy down here, once he's configured for OSPF, is going to get those advertisements. He's going to be like, oh, I already knew about this one because I'm plugged into it, but I did not know about this one behind you, so let's do it. Oh, wait a sec. I'm drawing this all up like I'm on router 1, but I'm really on, I configured router 2 first. So same concept, just flip the arrows, right? So I was working on router 2. So hello, hello, hello. So we got to go up to router 1. So I didn't, I'll say if I would have had the network commands, I would have messed it up then because I would have typed in router 1's network. But since I did it on the interface, it's the same thing. Now let's go back here. I'm going to do a show IPv6 protocols. Just like in the old world, we had show IP protocols, which was the version 4. It's just saying, hey, I'm running OSPF on serial 00 and fast Ethernet 0/0. Okay, let's go to router 1. Router 1, where are you? There we go. Okay, so I'm going to go, well, I'm on router 1. Let's do a show IPv6 protocols. I got nothing. Connected and static. We've got no OSPF relationships at all. So let's go into a global config, IPv6 router OSPF, process ID 1. It's fine. Remember, that does not have to match between the two sites. Now, I'm going to go in here and give it a router ID. Now, this isn't an optional thing. If the router doesn't have a name, if it doesn't have a router ID, OSPF won't start. Can't say hello unless it has a name to introduce itself by. So now I'm going to go into interface fast Ethernet. Let's go there first. Fast Ethernet 0/0, IPv6 OSPF, and we will say this guy. And by the way, I'm just going in and saying you belong. Essentially, let me just say this. Now what we do, this is how the process works, is on the router, I create the router OSPF process. I say, okay, I'm now running OSPF. We do that in global config mode when we type in that IPv6 router OSPF1, right? So it's like we activate this process of router OSPF, and I say, okay, I'm now going to add fast Ethernet 0/0 to that process. So now it's doing OSPF, sending hello messages, advertising itself, its network. I'm going to add serial 0/0 to that process. So it's like think of it like if this were a wizard, we'd be dragging and dropping interfaces into the OSPF process bucket and leaving them there. So instead of previously, we would go under OSPF and configure it with these little goggles to say, hey, this network command, now go out and find all of the interfaces that start with 200. Remember the old IPv4, the current IPv4 flavor of OSPF. So now it's like we're putting the interfaces into the bucket instead. So I'm going to and what I was saying, all this other stuff is like if I want to change my hello timer, how often I say hello, my dead interval, how long until I declare a neighbor dead, the cost of I can tweak this thing all out, but to make it work, I'm just going to say this interface, fast Ethernet 0/0, is under the process ID 1, and it is all part of area 0, one big ol' area. So I'll exit back out here, and we'll go under interface serial 0/0. IPv6 OSPF1 area 0. Right? I've now dragged those two interfaces into the bucket. Ooh, look at that. We've got a message. It says OSPF v3 process 1 has changed. I see neighbor 2.2.22. If somebody came to me and said my name is 2222 on serial 0/0, I've moved from loading to full. That means I'm a full neighbor. Let's do a show IPv6 OSPF neighbor. And I can see, same output as the show IP OSPF neighbor as before. I see I now have a full neighbor relationships. Let's check our routing table. Show IPv6 route, and look, OSPF. OSPF has now educated my router 1 about this 56 route. Come on, we got to ping it. Ping IPv6 2001:56 : caps lock, : 1. Cha-ching. We're over there, and now I can go up to router 2 as well and do the show IPv6 route. Okay, we got to ping it. You can't just leave something unpung. What's the past tense of ping? Pung? 2001:55::1. I've pung it. So it is now communicating fully between the two. Tell me that's not awesome. I mean, think about this. I mean, in one nugget, we've now taken all these base concepts. I mean, it took us a long time in IPv4 to understand it all, to learn it all. But are you starting to feel like this jump to IPv6 may not be as monumental as most may think? I mean, yeah, it takes a little while to get used to those new addresses, those big old hairy addresses, and the new way the subnet mask looks. But for the most part, I mean, we did almost what took us probably half this series to do in IPv4 in one nugget with IPv6. What that tells me is IPv6, it brings some new concepts, brings some new feature, but the core of networking is still the same. It's still the same car, right? We just switched out the engine. We still have seats. We still have a wheel. It all does the same stuff, maybe a little faster, maybe a little better. But IPv6 shouldn't rock our world like I think most people think it will. It's a big transition. Yes, there's a lot of work involved. Yes, but conceptually, not too bad. So how do we make that jump? How do we get a smooth, non-pressured transition to IPv6? I would say now Cisco approved and recommended way to make a transition is this guy, dual stack routers. So here's the idea. I can run, I mean, you can see right here on router 1, let's do a show IPv6 interface brief. It shows these IPv6 addresses that are on there, right? So we're running IPv6. Show IP interface brief, right? All completely unassigned. Want to see this method? Here it is in 30 seconds or less. Ta-da! We have just created a dual stack router. Essentially, we've got now, I mean, if we were to diagram this, we've got the router, we'll say router 1, that has an interface that has, let's just say, a couple clients on there. The interface has two different IP addresses, an IPv6 address and an IPv4 address. So the beauty is now we can have our clients still running. Let's say that guy's running Windows 7. You know, he's got an IPv4 address assigned to that. We haven't made the transition yet. He's 192.168. What did I say? 0.50. Did I give it 1 or 0? Yeah, so 0.50. He's pointing to the default gateway of 0.1. Life is good for them. He never notices that there's a problem or anything is changing. We've got the IPv6 address, so this guy's running, I'll just say Windows 8 or beyond, and it's got an IPv6 address, and its default gateway points to this right here. This router, it's like a bilingual router. That's all there is to it, to where he speaks IPv4. English and then IPv6 Spanish, you know, so he can speak the two languages at the same time on the same interface. This is probably the least changing of your network. Like, you can do that because you can have, you know, a WAN link now with an IPv6 address over here, IPv4 address over here. Maybe this goes to the internet, right? And your service provider can do the dual stack thing, and you can do you can NAT these guys. Oh, did I put 6? You could NAT these guys out to a public v4 address, and you could, well, you don't even have to, right? Because there's bajillions of addresses out there. So you could just natively pass those guys through and route them, or you could even use NAT for IPv6. It's out there, so you could NAT them to an IPv6 public address if you wanted to do that too. So you can see you could make this change. You could say, you know what, organization, we're going to run IPv6 right now. I've just turned on IPv6 on our router interface, and now you just got to slowly move the clients over to IPv6 as you will. That is Cisco's best, you know, thumbs up method. If you look at all their white papers of how can we transition, that's the least impactful. But we have other ways. We can do tunneling, and what that means is, you know, let's say the world around us, we were slow, and the internet became IPv6, and the whole IPv4 internet is shut down, right? We can actually still run IPv4 on our networks. Think of this like a VPN, right? IPv4 over here, and I can actually tunnel that through the IPv6 internet to where I can run IPv4 on both sides and still communicate through this tunnel like a VPN. More likely is the early adopters. You probably won't see much of that. You'll see people that are like, oh man, we're ready. We're going IPv6, but the internet connection has not caught up yet. So it's still IPv4, same concept. You can create, that's why I say 6 to 4 or 4 to 6. I can do a 6 to 4 tunnel to where I'm tunneling IPv6 through an IPv4 internet, or it doesn't have to be the internet. Could be a WAN link, could be a service provider, could be anything that just has not converted as of yet. So you can slowly bring up your networks one by one to IPv6 and tunnel them to each other. Pretty cool. Last one is NAT. They modified NAT to where it does protocol translation, NAT PT, to where I can have, let's just say we've got the IPv4 internet as it stands today, and I've decided to be that early adopter, and I'm running IPv6 on my internal network. NAT PT allows me, or IPT, NAT PT allows me to take those v6 addresses and NAT them out to a v4 address. Let's just say 200.111. So it hides the entire IPv6 network behind the scenes and just comes out as a version 4 public address. So I know I've said this a couple of times, moving to IPv6 is not going to be a Y2K experience. It's not going to be one day you wake up and you're like, oh man, November 3rd, I've got to convert, you know, or something. You know, you've got to run to that date and beat that. IPv4 will be around for a long time. Can I say how long? I don't know. I would 20 years. Let me throw another wild prediction that by the time I get there, I'll totally forget it and nobody will call me on it anyway. 20 years, IPv4 is gone, right? IPv6 has taken over as its entirety. Does that mean you cannot run IPv4? No, it does not. You can use those migration strategies for a long time to come. So we've seen. you've got to feel a little better about IPv6 after seeing this nugget, right? We've seen how we can go in and assign IPv6 addresses to your router, verify those addresses, turn on routing, both static routing and OSPF, same command, same concept as before, same car, it's just a different engine. We put IPv6 in front of all the commands, and now we can start routing the IPv6 addresses. And then finally we saw how we can migrate over, how we can cut over from IPv4 to v6. Well, I hope this has been informative for you, and I'd like to thank you for viewing.